Hi there, Mr. Lavon. For my Math 12 pre-calc project, I have decided to do the Unit 8 binomial theorem. Before we start with some problems that we will learn, we should firstly want to know what the binomial theorem may help us do. The big thing that it does is that it helps us expand binomial terms that can get very long and complex, like x plus 3y all to the 7. As well, it can help us determine the nth term in a binomial term. It can also help us determine the middle term, the constant term, and a term to the nth degree polynomial. The formula used is t k plus 1 equals n choose k, a, n minus k, and b to the k. Well, where does this formula come from? We know that this formula comes from Pascal's triangle, where it starts off with n choose 0 plus n choose 1 plus n choose 2, and so on and so on. The first question that we will look at is find the nth term. This question asks to find the 7th term. When we are doing these types of problems, we always want to get 4 term things: k, n, a, and b. Well, n is easy. N is always the degree of the polynomial. We know it's 9. K, well, k doesn't equal 7, it equals 6, since k plus 1 equals 7, which is equal to 6. A is equal to the first term, which is equal to 2x, and b equals the second term. But for b, we always have to remember to put the sign, whether it be positive or negative. This is a fairly easy problem, since really, once we get everything, we just plug into the equation. So the equation that we will get is 9 choose 6, 2x to the 9 minus 6 equals 3, times negative 3y to the 6. From here we simplify for 84 times 8x to the 3 times 729 y to the 6 for a final answer of 489,888 x to the 3 y to the 6. The next problem asks to find the constant term. So what does it mean by the constant term? Well, really, it means finding k. But once we find k, we must remember to add 1 since the equation is 2t k plus 1. We should probably plug everything in to see what we have. For n equals 6, k equals, well, that's what we want, a equals 1 over x squared, and b equals negative 2y. So once we have these, we should probably start plugging them into the equation, which we will do to get 6 choose k times 1 over x squared to the 6 minus k times negative 2x to the k. Now, this is where it might get a little complicated. And we have to know that we have to use our exponent rules. We should probably bring the 1 over x squared over to get x to the negative 2. Also, since we will be working with exponents, we will cancel out what we have in the n choose 6 and the negative 2. And that is about it, because if we use our exponent rules and multiply the exponents into the higher exponents above them, we can get x, which will equal negative 12 plus k plus the other k once we have lined them up, to get negative 12 plus 2k plus k to get k equals 4. And as mentioned, we have to know that we must add the k, and we must add 1 to the k, which equals 4, when 2k plus 1, to get the constant term, or k, to equal 5. Finally, the last problem asks to find the middle term. Really, it actually really means to find k again. However, we must do something different. The first thing is, what is a middle term? The middle term, well, that's the middle term in the expansion. We realize that n equals even number, and then we can add 2 to it and divide by 2 to get k. However, we must subtract 1 from k, as in the equation it is 2k plus 1. My excuses, I meant to say tk plus 1 and anywhere else in case I missed it. Now we have k, we are ready to start plugging in and get our value wanted. We know that n equals 8, k, well we got it, it's 4, a equals 3x, and b equals negative 1 over y. Now just simplify and put it into the equation. If we put it into the equation, we will get 8 choose 4 times 3x to the 8 minus 4, which equals 4, times negative 1 over y to the 4th, which really equals negative y to the negative 4. And once we simplify that, we will get 70 times 81 x to the 4 times y to the negative 4 if we flip it over, for a final answer of 5,670 x4 and y to the negative 4. Or for y, you can flip it over again to get 1 over y to the 4th, whatever you like best. Well, that's about it for the binomial theorem. Hope you enjoyed.